Hey, seventh graders. All right, so today we're going to compare populations. This is a readiness TEK, which means that this is going to be something you really need to know. It will be highly tested on the STAR test more than some of the others. So this is something I want to make sure that you guys understand. It's comparing populations. And what we're going to do is we're going to use two box and whisker plots and compare some population or some data. It doesn't really mean population of people, but the data. And then we're going to use two dot plots to compare population or our data. Okay, so it's not hard, but you do need to be ready to understand it. All right, guys, good luck today. We're going to start this lesson 6 with compare populations. Again, I got this all out of the textbook. You can find all these in a self-check if you want. So let's look at this. We're going to compare populations. So we're going to compare the centers and variation of two populations in each exercise. We're going to round to the nearest tenth if necessary, and we're going to write an inference that we can draw about the two different populations. So let's look at number 1 right now. The double plot shows the daily attendance for 2 fitness clubs for 1 month, okay? So we have fitness club daily attendance right here, and we've got this fitness club's graph, it's a box and whiskers, Fun Fit, and we can see that Fun Fit's minimum attendance is 80, and then its maximum attendance is 140. And we can see the daily average is 100 for the attendance. This is the middle, okay? And then here is the range, okay? And then we have Greg's Gym, and we can see its daily average minimum attendance is 90, and its maximum is 140, and they average about 120 people showing up to Greg's Gym a day. So what we're going to do is, all right, so the median of this data is 120. Well, I'm sorry, for Fun Fit is about 120. This is the median. And then Greg's attendance, or median, is 120 also, right here. If you say 80, 90, so if we did this, let's see. Fun Fit, sorry. I'm going to put FF for Fun Fit. So we have 80, 90, 80, 90, 100, 120, 120, and 140. And then we have Greg's Gym, GG, and we have 90, 110, 120, 130, and then 140. And actually, let's see, the median of Fun Fit is 100 and 120 for Greg's Gym. So it's a little bit different. All right, so let's look at the variation. The variation in Fun Fit, if I take the interquartile range, 120, and I subtract it from 90, I get 30. So Fun Fit's a 30 variance, right? And then if we look at Greg's Gym, we can take 130 and subtract it from its low, 110, and we get a 20 variance, 20 variance. I have great handwriting. All right, so if I was going to compare these two, what I would say is that Greg's Gym has a greater attendance, right? Obviously, it has a greater attendance overall because its its minimum attendance is 90. Its average attendance a day is 120, where Fun Fit is 100 a day. All right, so overall, Greg's Gym has a higher attendance rate. And it has a smaller variance. Its variance is only 20. It only varies about 20 people, okay, where Fun Fit varies about 30 people, okay? So I hope that you understood that. We're going to do dot plots next. This part is going to be confusing when we find the center of variation for the number 2. So let's look at this. And I actually just taught this to 8th graders and 7th grade honors this week, or last week for y'all. Okay, so number 2 says the double dot plot shows the weights in pounds of several house cats and small dogs. Okay, so this top one is house cats, and then we have small dogs. All right, so what we can look at this, and we want to know, we want to compare their centers of variation, and then we want to write an inference that what we can draw about the two populations. Hold on one second. All right, so what we're going to do is we've got to find the mean absolute deviation, and it's going to be kind of confusing. So, but look at this. This is a symmetrical, the data is symmetrical. So we can see that the house cats average, the mean is going to be 11. So right there, we didn't have to do that. We didn't have to find the average. So we know house cats, and I'm just going to put it up here. House cats is 11, and then small dogs is going to be, we can see that also is symmetrical, and its average small dogs is going to be 9 pounds. Okay, so we can see that. So what we have to do now is we're going to find house cats first. So we have to look and see the total. We do have to do some math. So we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 dogs, 9 house cats. Okay, there's 9 of them. So now we're going to do what we call, it's called MAD, M-A-D. You will do this next year. The mean absolute deviation. All right, so mean is average, absolute is absolute value, and then the deviation is how does it deviate from the mean. So what we're going to do is we're going to take this up here, this 9, and we're going to subtract it from 11, or 11 minus 9, and 11 minus 9 is what? 2, right? And then we have 10, and 11 minus 10 is 1, but we have 2 dots right there. So we're going to have to do 1 plus 1, or you could do another 2. Then we have 3 11s, so that's 0. So that's, we don't even have to add those 3 zeros. And then we have 12 minus 11, which is 1, and we have 2 12s, so we've got to put down 1 2 times, or we could put down 2, and then we have 13, and 13 minus 11 is 2, so we're going to add 2. So we're going to add these up. So I've got 1, 2, 3, 4, plus 2 is 6, plus 2 is 8. So we're going to do 8 divided by 9. Okay, 9 will go into 80 8 times. 8 times 9 is 72, and that is 8, and it's a repeating decimal. So we can round that to the, I'm going to put MAD, is about 0.9, rounding to the nearest tenth, okay? So next, we've got to find the central tendency, central variation for small dogs. Okay, so let's look at this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 small dogs. Okay, so it's a little bit more. And we're going to do the same thing. We're going to do 9. We're taking the average, the mean, 9, and we're subtracting it from each value to see. Basically what we're saying is how far is each dot away from the average. Okay, so 9 minus 6 is 3. So we're going to do 3 plus, and then we have 7. 9 minus 7 is 2. So we're going to do plus 2. It's 2 away. That means it's 2 away from the average. So we have 2 8s. 9 minus 8 is 1, but we have 2 of them. So this time, instead of doing 1 plus 1, I'm going to do plus 2. Okay? And then we have 3 9s, which would be 3 zeros. So we could put plus 0, plus 0, plus 0, but it doesn't matter. And then we've got 10 minus 9, which is 1. And I have 2 of those, so I'm going to do plus 2 again. And then 11 minus 9 is 2. So I'm going to put plus 2 again. And then 12 minus 9 is 3. So I'm going to put plus 3. And if I add these up, 2, 4, 6, 8, and then 6, which is 14. So 14 minus 11, divided by 11. 11 goes in there 1 time. I have to add 0. 11 goes into 30 2 times, which would be 22. We have 8, 0. 11 goes into 80 7 times. So that's going to make that mean absolute deviation is going to be 1.3 if we're rounding. I don't even have to go all the way. All right, so I've got that. All right, so now let's go back and read our question. What was it asking us to find? Okay, so it says, compare the centers of variations for the two populations in each exercise. Round to the nearest tenth if necessary, and then write an inference that we can draw about the two populations. So if I'm looking at these house cats and small dogs, okay, so I can see that the small dogs have a variation of 1.3 pounds, where a house cat has a smaller variation of 0.9 pounds, so basically 1 pound. So it's very similar and very close. But if you can just look at the graphs, the dot plot, and you can see that obviously house cats are going to weigh a little more than small dogs. So that would be the population. So this MAD, mean absolute deviation, I'm going to put my 8th grade lesson on here for you guys to watch. It may make a little more sense. Feel free to watch it. It is a little confusing, but obviously you're going to need it. So anyway, I hope you understood that, and good luck.